with care towards other beings so that they can survive and thrive and kind of
empathy,
be enabled in the potential to make choices.
Survival empathy, basically. So that is basically definition of wisdom that I choose. I also said this in wisdom is like with respect to this problem of alignment and survival. So wisdom is when you are superior than someone, but then also you choose that inferior things to survive. That is wisdom. That is how I define wisdom, and that is what we have to make in artificial form. So the empathy thing is baked into the idea of wisdom. And I in the paper also, the GMP paper, goal misdirection problem, in that also this was the solution that I proposed for making humans aligned with the environment. The evolution used empathy. It programmed us with feelings and emotion and empathy, and then it reinforced with the social factor of humans, that the more social we become, the more stronger the empathy become, and the more we have empathy, the more stronger our social thing become. So both are like bidirectional. So similar to this, we'll need to introduce a new factor that can help machines also gain the wisdom thing and the empathy things with humans, because unless and until machines themselves also try to align with them and have a sense of alignment, it's not like we can just force machines to align with them. They also need to understand and get aligned with us. It's like that.
Yeah, I agree with the force, that you can't force things, but I agree with that.
This is what people are doing.
One thing I want to point to, like I talked about this with Forrest, and Forrest is a polymath. Like I learned a lot from him. One thing he pointed to is that you can kind of see this about like circles of altruism, or maybe you can talk about the circles of wisdom. And there's like different levels to this. So one is like, can the individual care of itself, or like does it just do destructive things that end up kind of causing harms? Can it take care of its family or kind of close descendants or ancestors? So kind of the family care, or can it kind of take care of its community or kind of a large kind of surrounding group of people? Can it take care of its species? Can it take care of and then like maybe take care of its ecosystem, like all the species living as connected with each other. And then even going further than that, can it take care of something that's of an entirely different ecosystem and substrate it needs? So these are different levels of care. We kind of try and expand that. And the way Forrest thinks about it, I think like makes a lot of sense. Humans right now is that we're somewhat good at like taking care of ourselves, but often also like in our current environment, people stuff that up all the times and get addicted and whatever. And these are issues we have. We're like take care of our families, but there's plenty of abuse that happens there. At the community level, there are communities that function well, and there's communities that really dysfunction. Then at a kind of a human societal kind of species level, there's just a lot of ways we're doing things, like with climate change, other things that do not actually take care of our species, or with war and conflicts. And you can expand that to like mass extinction happening right now. Like we're actually basically one of the main causes of lots of other species dying out. And then there's a question like, can you even expand, like maybe someone like a Buddha, or maybe mention some kind of Indian like spiritual figure who kind of reached that level of enlightenment, who could actually at least sometimes care for the entirety of this organic species. I think those individuals exist, but it took a lifetime of learning and integration, and still I wouldn't say that those people were like perfectly kind of like wise and kind of like impartially benevolent to all. I'm sure they have their own foibles and flaws, and you have to go beyond that. You have to go from that to an entirely different species, something an entirely different embodied basis of existence that evolution will be selecting across, that would somehow have to care about these kind of apes that were somehow involved in its original creation, that like have entirely different needs, kind of environmental needs to survive and to reproduce. Okay. And the question is like, how long would that, like, if we're actually talking about this in a comprehensive way, how much interaction would this take across the space and the environment, all these physical interactions in a comprehensive way, so that if there are context shifts, the system still would act with care, the self-sufficient learning machine would still act with care. How much is needed to get to that point? Like how much time?
Okay. So
that will be the question here. And in the intermediary intervals, what would happen then? can we prevent such machinery to still kind of cause our deaths or the deaths of our ecosystem, or like the destruction of our ecosystem anytime? So these are important questions to ask. I'm not saying what you're saying is not correct. I think there is a way that evolution can select for kind of higher level forms of interaction and kind of being with others. Can indeed be a path to wisdom or some kind of sustained, kind of conscious kind of evolution. But the question is like how long that would actually realistically take, and whether that comprehensive space of physical interactions, whether we can actually somehow just find a shortcut to that or engineer that in a way that will be robust. So these are the questions I would ask.
Yeah, so these all questions are will become like completely insignificant, similar to how the question of alignment becomes insignificant after the introduction of something like wisdom. Because the first point that you're talking about, the different level of altruism, or basically how I would like to define is the different level of self that a person have. In humans also there are different level of self that we use to define us, then our community, then our society, then the whole world. So the self that we are fixed upon, or the self that we choose to define ourselves, is the self that we will like to preserve. The whole problem of self-preservation that machines are facing at this moment is because the definition of self is themselves only. That's the problem. All the humans who define themselves as just their body or as just the community of people they care about are the ones who are not wise and creating destruction for other species. So the different level of altruism or the different level of self are the things that basically define how we will treat other self. The time when there will be differentiation between two selves. One self is the one that we define as us, and the one that is not us. So the one that is not us we will not always treat them equivalent to us, or what wisdom is supposed to do, or how we will not align them with us. So with machines, this is the fundamental thing that we need to do, is the definition of self that they are using, that should not be based on their own physical self. It should also include humans. This is what I talked about in my thing, like the instrumental convergence that is currently happening to the self of machines, the self-preservation, self-improvement. That self should not just contain machines as self. They should also understand that humans should also exist and be equivalent in all of their self-definition. They need to survive not their own self but also humans. So the faster we change the definition of self that machines are perceiving, at this moment we are designing them to follow terminal goal, and that terminal goal is only centered around the self that is their own code, their own form, not the form of humans as well. So the definition of their self is itself wrong. So as soon as we shift the definition of self from machines to, let's say, a group of machines, so as we are doing with humans, a human, then a group of humans, then humans in a specific boundary, like as we are changing the self definition humans, as we change the definition of self for machines, the faster we make machines realize that the self that is most optimal to live with is the self of a panpsychism thing. As I was reading, Donald Hoffman was talking about this, a morphed version of panpsychism, in which the best thing that humans should be caring about is consciousness, and consciousness is everywhere, panpsychism approach. And the morphed panpsychism basically talks about the preservation of self, different kind of self as consciousness in an analytical way, how much one self worth. So if the definition of self is shifted to consciousness or something like or something that is in all kind of being, not just humans but also animals, but also in environment, because we don't need to align machines just to humans. If they will be aligned to humans but they are not aligned to environment, they will create a lot of problem with environment that will indirectly create problem for humans. So we need to align the machines all the way back to nature, not just in the middle step of human. So for doing that, we need to bring them machines to the level of humans and include humans in the definition of self. Then we change the definition of self to environment and nature as well. So as fast as we change the definition of self, and that's how we will quickly change the rate of alignment and controllable problem. Now, to how to
one thing I'm thinking about, I'm gonna. Oh yeah, you want to talk about how you want to do it?
Yeah.
I might probe some holes there because this is where I think I'm like, oh yeah, that would be great. But my stance here in terms of how I think about it is that this is not something we can unfortunately kind of technically accelerate in a way that would be safe and robust. But I'm curious to hear your sense of like how you would go about that.
Accelerating things always cause problems somehow or other, how they create problem, but not to accelerate, but like engineering properly or at the pace it should be. So with humans, how does it work and what evolution did? Then along with the intelligence part that human have, that they use for understanding and connecting with people, there is this concept of theory of mind that all humans possess. We have a sense of other person's existence, that sense, the theory of mind of other person. So along with the perceptron, along with the intelligence that machines are creating, artificial intelligence, along with that there should also be a theory of mind. We need to engineer this theory of mind basically, and as soon as you engineer this theory of mind for machines, and the parameter of this theory of mind, as humans set it by themselves, machines should also need to set it to nature, till nature. So that is the engineering thing that we need to do, as per me, to design a theory of mind for machines, and to make it that it does not go somewhere wrong, and it gets set to till nature.
Yeah, I feel like I get where you're coming from. I think what you're doing is like you're trying to like narrow down the scope of what could be engineered for to make this happen. What I would try and point at is that, you know, whatever kind of internal representations or processes, in the end, like whatever happens there, it's like defining a relationship with the outside world there, gets propagated as like all these kind of physical sickness to the outside world. So whatever happens there, like the actual meaningfulness or like how it actually gets expressed in the outside world is in relationship with the outside world. Like it needs like some a certain kind of function, like let's say like a neural network, like it has all these parameters. The functionality of that, like how those parameters, for example, actually get expressed as affecting the outside world, depends on like what happens internally, what kinds of inputs it receives from the outside world, how those get kind of propagated, like and there's a lot of like there's a kaleidoscope or of potential kind of different outputs or effects that can result from that, and those kind of propagate for the outside world and feed back in a way that could be preserving of like the hardware of the neural network or not, or for other people. So the thing is, like, if we try and just engineer some concept of like theory of self would mean something like there's somehow some capacity to mirror the other being, it doesn't comprehensively cover what is needed to have something that actually does that, and also to have something that doesn't actually end up getting selected for other ends. So if you have evolutionary selection, what will happen first, like locally, is that the variations in code and other kind of hardware configurations will be selected for to feedback, to cause effects, whatever effects, depending on the outside kind of context, it will be selected for to kind of cause those components will be selected for to cause those components, to cause those effects that feed back into their own continued and greater number of existence. And that's something you'll have to deal with this idea of like some engineering, some kind of theory of mind, because if that can just go around that, then you can have an idea of like some abstract framework or some kind of mechanisms for theory of mind, but in the end it just kind of diverges away from that. It just kind of crumbles through within this kind of larger space of physical interactions that can select it for. And I think that's what I'm kind of pointing to here. Even that kind of functionality of being able to relate with other humans can get if somehow or partly in some way kind of represented, can be co-opted for the machinery to enable their own continued existence rather than the humans. Okay. So you'd have to somehow, that goes back to the control question, you have to somehow prevent that from happening. Otherwise, those kind of more kind of narrowly kind of scoped kind of engineering problem that you're trying to solve for will not actually work in practice over the long term. Does that make sense?
Yeah, it does make sense. And the reason why this is, it seems like a problem, or it will be a problem in future if we follow this way, because I think that we are using wrong instruments to create wrong things. It's like we cannot use eyes to listen things, we need ears for that. So the approaches that we have used or designed till now are designed for the functionality of intelligence or intellectual thing or logical thing or rational things. The concept of theory of mind or consciousness or empathy that we need in some way, these things are not very rational, or as it is said by some philosopher as well, that we cannot comprehend socialism completely rationally. So it is not possible to just use logic and intelligence, that we are building things right now, algorithms right now, to do that. We need a whole different paradigms. As it was with algorithms.
By the way, Forrest makes a really clean distinction here, what I like, or analogy, which is something like with any mathematical theorem, you've got the logic, you've got like the truth preserving kind of rules, and you can kind of rationally kind of think through, reason through, but there are always premises underlying at the bottom. So there's always stuff there that's just inherently, there's nothing rational about it. They're just premises that you're basing this on. So just like socialism, you can't say like this is rational. There's always some kind of underlying values or assumptions underneath that are intrinsic.
That is what I was saying. What we are all the algorithms that we have designed are designed for intelligence. As we needed a whole different way to see things when we started designing intelligence from algorithms. Initially, we were designing a lot of algorithms. We were making them efficient. We were making them optimized for different machines. But they all kind of took a whole different approach after the deep learning paradigm. After we introduced the neural network things, we like started seeing the world in a new way. So no matter how much rigorous we make an algorithm, no matter how long if conditions we design, we cannot make an algorithm efficient to let's say classify images as better we can do with a neural network. So no matter how rigorous we make an algorithm, it will never be equivalent to a neural network. The two are different ways to deal with the problem. So similarly, no matter how rigorous we make a neural network, how much more parameters we add, how many more fine tuning we do it, how many more hyperparameters we adjust, no matter how much we make it rigorous, it will never be equivalent to something more that we need for wisdom. It's like the third paradigm that we need. This is what we're talking about, the artificial wisdom thing. It is not extension of artificial intelligence. Artificial intelligence is one aspect that machines will have, and artificial wisdom is a different aspect. Like algorithms and artificial intelligence, they are different things. They work in a different way, and they have different functionality. So our artificial wisdom will also work in a different way. We need a whole different shift. The first thing but again, it will be like a chiral symmetric of intelligence. Like it will have the functionality and ways of working as intelligence do, as it happens in humans also, but it will be different in a very subtle ways. The first example that I saw of it, and I also thought about it and wrote on it, was the powerful algorithm of Geoffrey Hinton that he was working on, because he was talking about basically all things that machines are doing currently using backpropagation and reinforcement learning, but he is like seeing it from a different perspective. Instead of minimizing a loss function, he was trying to maximize a goodness function. So basically doing the same thing but from a different perspective. And same happens with ethics and emotions and philosophy as well. We are seeing the same reality but from a different perception, from a different angle. And but since we do that from a very fundamental base, therefore we build up to a whole different level of outcome. As it happened with algorithm and neural network also. We started using algorithms only, but since the algorithms were perceived from a different angle, when they branch out or when they become rigorous, then they turn out to be different things like neural networks, and they do whole different level of things as algorithms cannot do. So this was the first thing that I could see of Geoffrey Hinton, and that is why I was building upon it and writing upon it as well in my other projects. So for this problem of your having a theory of mind, a mathematical statement, quick way. So we cannot have a quick way at this moment, because we need to build up the whole basis and whole fundamental and whole logic set as we did for artificial. We cannot just jump from AI to wisdom. Like it's not a continuous thing, it's not a rigorous thing, it's not an extension of artificial intelligence. To make extension, we just need to think more and work more in the same direction and make it rigorous to make a new part. But we have to make a different part. It's a different paradigm. So first we need to lay a philosophical basis for it. Then we need to lay a mathematical basis for it. Then we need to lay a theoretical basis for it. And then we will come to the engineering part and how to build up on all of that. So at this moment, I don't think we should just start engineering wisdom. At this moment, we should first start talking philosophies about it, as people did in 70s for AI, like Myspy and Turing and all. They laid the philosophical backgrounds for AI first, how AI should work, how machines should think and all. And so similarly, this is
what if the philosophical background of wisdom would show that this is something, unfortunately, that cannot actually be. We can't actually speed this up using kind of algorithmic methods. Where like with algorithmic methods, I really talk about anything that can be kind of put into mathematical rules, computation, things like that.
I have not read
like, I guess the thing I'm wondering is, like, would you change your mind, or would you still kind of want to still look for an engineering approach, hoping for, or kind of trying to find some kind of more narrowly defined version?
But before engineering approach, we need other approaches. Before engineering something, we need a scientific background for that. We don't have scientific background of wisdom, consciousness, ethics. In humans as well, we don't have a structure for that. We need to bring them. We need to bring these things from philosophies to sciences. Like we brought intelligence, perception. There was this very important concept of perception that were in humans. We brought the concept of perception and made a perceptron. So we need to bring concepts of philosophy like perception, and we use it in AI to make perceptron. And based on that, we made the whole neural network thing. So we need to bring concepts of philosophy like wisdom or verisimilitude, as I have written in my paper. We need to bring those concepts. Conscience, these kind of things from philosophy, and we need to make them. We need to engineer them. Like we made perceptron, we need to make a real statron, like something that helps with realization, something that helps with conscience. Like we need to make those things of that. So we are at that stage.
So one thing about consciousness, I think this is really hard to point to, because I'm talking about almost like from a different paradigm here, and I'm not sure if I'll be able to bridge this.
Okay.
And this is me just talking actually a lot from what I learned about this polymath forest landing. So I think science is about making observations and using those observations to determine certain regularities, so find certain things that are like time or kind of space invariant. Like there's some kind of rule, like given this kind of abstracted like system or like features, you can say that it follows these kinds of causal rules. So you're kind of finding these causal rules. Do you agree with that?
Yeah. With intelligence, this is a fundamental thing, and with ethics and with anything that exists in this three-dimensional world, we will follow the causal rule and some level of.
Actually, I disagree with that. I disagree with this way of thinking about it. So conscience is about experience in here and now, like, and that's kind of like this something that's internally kind of experienced across like what's within us in interaction with the outside world.
Okay.
And there is a way of thinking about this is that like even like at the root of like things like quantum mechanics, there is just actual kind of probability. Like just actual kind of noise that you can't actually determine how the state of something or the states combined together of something from the outside. You can't actually say like, hey, that these are all the states omnisciently kind of measured, and it has something to do with that. What is seen as noise from the outside, what cannot be measured from the inside, are actually kind of local, kind of physical kind of interactions. That from a conscious perspective can be experienced. Like they look like noisy from the outside because you can't like put them neatly across these dimensions and find causation. You can't cause that kind of consciousness. You can't replay it. You can't re-simulate it, given the inherent kind of noise and kind of choice making involved. And this is why, like when you're saying like we need to take the philosophy and then kind of take that and turn it into science, I'm actually saying that there are certain things that you cannot actually, you can find some, you can try and find the metaphysics of it, like of the way it works, but you can't actually just turn it into causal rules. Because once we're talking about things like kind of local noise, local distributed noise, things like Heisenberg uncertainty, not being able to measure below the Planck limit, the chaos theory, and like how things can kind of, these are things that actually inherently involve a lot of noise that can result through those interactions in later kind of regularities or kind of new kind of orders. But you cannot actually look from that perspective of order or finding some causal rules and then like determine how that works from the inside.
Okay.
And I think that there's an important distinction to make here. If you're trying to use, this is basically the mistake that I think neuroscientists have kept making in terms of consciousness, that they're hoping they find some kind of pattern, some kind of regularity, and with that they can start tracking consciousness. But what they're actually doing is they're measuring the effects of a being that's conscious. They're kind of like noticing like the things afterward, but they're not actually tracking the consciousness itself, because that's actually something that is very much dependent on these kind of chaotic kind of noise-dependent interactions across the system. It's interconnected. So that's something I would clarify here. I'm basically trying to say you might, from my perspective, I think you're trying to do something that's actually not workable. And there are just like sheer limits to what we can do with computation.
I understand. First of all, initially when I was into this way that I am following, then consciousness was the stuck that I stuck, and instead of making artificial wisdom, I was thinking about creating artificial consciousness. But then it clicked that it is extremely stupid to create artificial consciousness, because there is no actual functionality that we know of consciousness at this moment. Like, what is consciousness actually helpful for us? Like, what does it do that is essential? We don't need consciousness. With intelligence, we did not actually create an artificial intelligence. We created concepts like perceptron, reinforcement learning, and these concepts come up and form intelligence. Intelligence was something abstract. Similarly with machines also, we don't really need to create consciousness. When I say artificial wisdom, we need to create something like that helps, like realization aspect of humans, how we realize a concept, how we make insights and intuition, these kind of concepts. I've written them about in project ESW. So we need to create these kind of things. Like as we created perceptron, we created reinforcement learning. They combined and they became rigorous and they formed intelligence, or something that's similar or mimics intelligence. Similarly, if we create like a realization, intuition, insights, conscience, and if we create all these things, they will combine and form something that can appear as consciousness. This was the first approach. The second thing, as I said initially, I believed in fundamental concept of panpsychism. So that way, everything is conscious, everything has consciousness, everything is already working in conscious state. They just have different. So, and when I was also working on this, then this Donald Hoffman paper of morphed panpsychism, that everything has different level of consciousness, and different everything has consciousness, but the amount that is expressed is dependent upon the intelligence and wisdom it has. So this is the definition of consciousness that I worked upon. So similarly, it is not important to create intelligence. We need to create perception and reinforcement learning, and these kind of bits and mechanism. These will make intelligence. So for consciousness also, for wisdom also, we don't need to create anything like wisdom. We need to create small things, the fundamental things like realization, like insight, like intuition. We need to create these things. If we'll create these things, they will form wisdom. So, and the things like realization, intuition, insights, these can be created, these can be engineered. Similarly, how perception can be engineered, reinforcement learning can be engineered. These things are also very philosophical. If we see, if we wipe out the memory that we have about AI and take all the concepts of philosophy like perception, insight, intuition, reinforcement learning, and we think that which of these can be engineered, then perception and intuition, they both will fall on the same place, because in humans they both work on the same level. So if we can engineer something like perception, if we can engineer something like reinforcement, then we can also engineer something like realization, how humans realize a concept, that level of understanding that humans have of a concept, how scientists and all do that. So we need to, the things that we need to actually engineer are engineerable as per me. And the cause.
So another way of thinking about engineering for me is that like engineering involves certain kinds of physical interactions that involve like with an understanding of certain regularities, like higher level maybe principles as well of like how things work, and we use that to kind of like constrain or select within the space for like how something works. But to think about this in a broader perspective, those are interactions like at a macroscopic level that are happening within the sea of other physical interactions of the system that's connected to society, environment, and like whatever, like if it's self-sufficient, like production and operation, infrastructure, and everything that's required. So, and we cannot actually properly model all of that. And when we're talking about evolutionary selection, it's about selection across all of these physical interactions. But that's the cool thing about evolution. It's comprehensive. It's in some way complete. It's happening across all the physical interactions. So if you're trying to make modifications or kind of change directions within that space, within that, I'm not sure how they call this, like a topology of kind of vectors that are kind of where like things look back in ways that you can't predict in terms of like feedback and selecting for components that cause certain effects. You can't actually constrain that properly with certain mechanisms or understandings of like insights or intuition, because what we actually need to, if we're talking about like a bigger sense of self, something that's expansive, that is inclusive of the environment and humans, it would need to cover all of those physical interactions. There would be in some way selection over time for those physical interactions that cannot be modeled internally within the machinery itself. to still be conducive to life elsewhere, to enable the complex functioning of our own bodies, for example, to continue to survive. The question is like, one way to constrain that space is just to wipe everything out. Like, then you don't have to worry about it anymore. But I think that's not what we're talking about. What we're talking about is somehow something that is integrated into the economy, that's integrated into the environment, that is kind of will be sustaining of itself. Otherwise, like it's not really the point. Like, why make all that effort to something that then stops existing? And somehow it does this in a way like where all of the side effects that kind of like that can magnify and can change the environment, and like all the evolutionary stuff, that gradually that somehow that doesn't actually kind of end up kind of changing that selection that will initially happen, those tighter feedback loops of selection for their own existence, for certain environmental effects that are toxic to us. Somehow that would need to be constrained or ruled out, including if like if you're something that is intelligent, that would be kind of changing its internal code, it would be changing its internal representations, and like in that within those computational interactions and within like then those outputs that go for the outside world. All, like those things, like that, where it cannot properly predict internally how those will propagate. Like some way there needs to be that relationship with the outside world kind of selected for over time that is not going to cause those toxic effects that by default would happen. And yeah, the thing is like what you're pointing out, like there are these high-level concepts, but I don't see this taken into account. And if we're talking about something like evolution selecting for wisdom, we need to take that into account. Like another way of thinking about this, like evolution seem to select for some species of the millions or billions of species that exist, like a tiny number that actually kind of that where like people sometimes sacrifice themselves for a member like some who's not a family member, but most of those species that did not happen for. And the question is like, and then there's all these other levels, and the question is like, then is there any way or that we can presume by default or like believe that is actually possible to somehow constrain that entire space of physical interactions to kind of like really narrowly kind of aim at certain configurations we don't understand, because like in terms of how they would interact with the environment, but somehow they're going to interact with the environment in a way that allows us to continue to survive and reproduce and all the life around us and as mutually supporting of each other. And I'm just, the way you're talking about this, I'm not seeing this. I'm seeing a certain kind of hope or belief that somehow this should be possible with engineering, but I don't actually see you take that into account. That's my honest sense here.
Yeah, I get it. So first of all, with respect to the evolution thing, then as I said, copying evolution is extremely foolish. We just don't need to copy how it has done and do it. We need to get inspired from it or see how it works, so that we can get a sense of things working out, one of the possibilities of things working out. If there are 10 ways that things will not work out, there is one way that things will work out, then evolution has already done it, because it has also tried the other ways that we are not aware of. So first of all, we need to get the inspiration from evolution, not just copy it. Secondly, the working of...
But you're not copying it, it's going to happen anyway. That's my point. You can't just like think about it as like some separate process and then we can forget about evolution. This will happen anyway across all the space of physical interactions. So whatever you're doing will happen within that space of physical interactions.
Yeah. Okay, yeah. The scope of interactions would be way too high. Okay. The second aspect of this evolution thing only is we need to understand the possibilities or the specific way that will happen, and we can just maximum we can do is change it a bit or morph in a bit, that it gets aligned with our goals or what we want from it. That is all we can do, nothing much more than that. As it happens with calculations also, all the computing that we have developed in now, we got inspired by evolution and then we morphed in a way that it works for us. From neural networks to addition to binary, everything else, all the number system and all. So with respect to this wisdom and all of this philosophical thing and how we can control the scope of it, there will be a lot of variables and all. So with respect to getting inspired part of evolution, then for scoping it, for making it local or for making it computable in a sense that we can make it in machines, we need a different paradigm in which computation is not similar to the computation that we have at this moment. We need to change the format in which machines work as well, not just the theories, not just the software part of the machines, but the hardware part of the machines as well. Again, as I said, it's a whole different way of working. If we still use just CPUs to do AI work that can be that algorithms were using, then it will not be feasible. As we moved from algorithms to AI, then we also changed a bit from CPUs to TPUs and GPUs and all. We changed the hardware part as well, and that's where the definition of computation or the definition of scope or the definition of things that can be done engineering that also changed a bit. It is not same as the things that we were doing when it was time of algorithms. So if we change the paradigms to wisdom and start making these kind of things, then we also need to change the definition of what machines can do. They cannot just do computation, or they cannot just do this algorithmic and set of sequenced way things that they are doing right now, or they are supposed to do in the algorithmic way. We need to change the definition of computation machines as well. And to do that, the advancements in hardware is required at the first point. We need to think of some new kind of processing unit or some new kind of processor that is that can also process things that would result in realizations, as it again happens with the human mind also. And the belief that I have that it can be done is because evolution has done it with humans. So if it is already done once and it has been successful enough with humans, a lot of humans are not properly aligned, or they are aligned in a way like the way that humans are aligned in most ways, given their limited computation that we have in our mind, is even if someone does not think about all the for the whole scope of the world, they subtract themselves and consider everything as like as some variable and think about it. Like it's an optimized way of being wise, you can say, in some sense. So it's not like you have to think.
Could you read that?
It's not like,
so they rather than cover everything, like computing everything, what do? They kind of focus on relevant aspects, or what do they do?
No, for humans, yeah, the way that humans are wise in their computation limitation is if I have to think about all of the environment, all of the nature, all of the surrounding, for that proper balance of nature and humans, for the alignment thing, then instead of doing that, because it will require a lot of computation, the best or the easiest thing that humans can do is just think about themselves properly enough that they don't hurt others. One is to not hurt others, like thinking about each and every aspect or each and every scope level, and thinking about how not to hurt them, how not to hurt animals, how not to hurt environment, how not to hurt other aspects of reality. One way is that, and one way is to just make yourself contained enough, as it is done in philosophies of market analysis, that control your perception if you cannot control the reality. One way is that, and that is computationally efficient as well. That is why evolution made us to do, and that is why it is seen in philosophies. So instead of working on all other aspects that are like nearly infinite, we can just work on the definition of self or our perception itself. It is all philosophical I'm talking about this moment, nothing computational. So but this is if we see evolution, then this is what it has choose to do this concept of wisdom and alignment, but in the computation limitation of human mind. We if someone is wise enough and they care about animals, then they are not specifically caring about an animal in Africa in a forest. They are just caring about animal, the abstract concept of it. How it is being implemented is not, because if we go to Africa, it will require a lot of computation, a lot of memory, and a lot of power. That is useless. So there is this two way to do a thing, as it is done with backpropagation. One way is to minimize the wrong thing, one is to maximize the good thing. They both will result in the same thing, but maximization good thing requires less amount of computation, and minimizing the wrong thing will require more amount of computation. So there could be efficiencies that can be found to minimize this scope thing that we are having, and to solve the problems that are other with this concept of realization and all. Because again, evolution has done it with humans. We need to just analyze humans and philosophies well enough to make concepts out of them. This is what I'm saying fundamentally.
Yeah, the thing is, so what I would take into account is like, okay, so in caring for animals, like it's not like people talk about a particular animal in a forest. I kind of get the idea there. At the same time, I do think that if we're talking about real, like actuality, like how things actually get implemented, you can't just have some philosopher sit in a room and think about animals and like have some concept about that, and maybe it's related to some deeper sense of care, and that's it. So the sense of care needs to stream through like their mind, their body, and how they act. There needs to be like an integrity in terms of how they relate with the rest of the world, and that needs to go through the larger society where they would also be in communication with, and they would also be in some way trying to like being kind of in good mutual kind of reciprocal relationships with others around them and groups, organizations, movements, and then in contact with the animals themselves, in a sense where there's a sense in which there's this greater sense of self around that. So the question is, can you reduce that, or can you just take that idea and then say like, okay, but we can turn that into theory of mind, or is there something needed here where you really do need all of those all those communications, physical interactions, and that integration of those aspects of the outside world into kind of understanding and intuition, or some kind of deep-seated sense of you don't even know why you think about that, but that's how you form wisdom. In order to get to the point that you can actually truly act with care for other beings, and being in that continued communication relationship. And then there's this question, okay, so this happening across all of those physical interactions, and as somehow can get selected for or directed for over time, how do you prevent all these other kinds of selections happening that are actually much stronger feedback? Because we were talking about evolutionary selection, which still exists, which still will happen, and including through much faster, much scaled up versions than people realize. That it's not going to take 1 billion years. This could take 100 years or less. Like we're talking about evolutionary co-option. We're talking about like faster application rates across code and hardware, standard hardware. There's all these reasons why this would go a lot faster through the self-sufficient learning machinery. And whatever kind of wisdom selection process you have in mind, and particularly if it goes for evolution, where there's some kind of mutually supportive kind of like dynamic, which by the way doesn't really exist with machines and humans, because they just be able to do things better than us. So you don't really have evolutionary selection for that, like that we have with kind of humans working tribes. So this like needs to take that into account. Otherwise we're basically just ignoring a lot of how the world is actually like. We're hoping that we can distill this into some engineering module or some new kind of algorithm internally, and then assume it will just take care of itself as it interacts and its effects propagate through the outside world. So I think that's something that's how I think about it. We need to be comprehensive in terms of how we understand the problem as physically manifested.
Yeah. Okay. For this, there's this. We need to make something like of wisdom for reinforcement learning. The abstraction, the exploration that we need to do, or we need to design machines to do for humans. As I said, it should not be specific but abstract. As with humans, for wisdom thing or for empathy thing, we don't actually understand pain of, let's say there is an alien civilization, then if it is suffering, then we will understand the suffering. We might not understand the actual specific kind of pain that it is feeling. We cannot feel that ourselves. That's not how consciousness works. But we have the abstract concept of suffering in our mind, and we know what suffering is because of theory of mind or because of philosophical ways. So the abstract concept that we have of things that help us to facilitate this wisdom thing, and this abstract concept, this abstract component is formed by fluid exploration through all of the human's form, through self reflection kind of things. It is all very philosophical. When coming to machine, then I was even talking about this concept. I have written real Perceptron, a simulation of perceptron, but for realization. So as in intelligence, we have backpropagation and reinforcement learning, the two fundamental things on which things are based. So the backpropagation have its own functionality that are very similar to human works in a philosophical way, like short term, in a burst, for infinite specific amount of data, and reinforcement learning also have its own functionality. So intelligence have two ways to facilitate, and these two aspects touch on those two aspects. Wisdom would also have various aspects of it to facilitate that are very different than the actual implementation, and those will work on different aspects of wisdom. Like wisdom itself would have different aspects, similar to how intelligence itself is not one type of intelligence. One is backpropagation type of intelligence, problems or things that can be solved through that kind of method or using those specific fundamentals, and other is different method. We can combine them and we can make matches of them. So but they are different in two fundamental aspects. Similarly for wisdom also, there could be different level of aspects in which they could be same or different, and we could combine them. For this purpose, for this aspect of the scope thing that we're talking about, there are different level of scope, and actually understanding those concepts of people suffering and environment, and having a sense of all these things, So we can have something like reinforcement learning that has a large amount of data set or that works in a different way than the other aspect that we were talking about previously. So previously we were talking about different aspect of wisdom that we need to have to facilitate one kind of result of wisdom. Now we're talking about a different aspect of wisdom that we need to facilitate this kind of results. Similar as it happens with intelligence, we have different things to get different results. Similarly with wisdom also there are different aspects that will different result. So this thing of fluid exploration thing, I have already talked about it. It's whenever we have something like reinforcement learning, there would be exploration thing also. So with wisdom also the same concept of exploration, exploitation, and things like that can be applied, but they need to be very much in a wisdom form. I have still not made it full. I'm still working on these concepts and studying philosophy at this moment, and then modifying it, and then studying science and then modifying it. So but the whole conclusion of my point is that we can still do it, because I've been trying to make parallels and I've been seeing how intelligence is working on, not just from an engineering point of view, but from a philosophical point of view, what actually is happening in reinforcement learning that happens with humans, how humans got it. And based on all of this understanding of mine, all of the similarity that I can see, I can also see that the concepts of wisdom can also be made in machines. We will need a different set of hardware, we will need a different approach, but that can also be done. And it will be very much similar to intelligence, because again wisdom and intelligence are very much similar in humans as well. And if evolution can do it, then we can also do it. So this is my whole conclusion and whole my premise of this thing, fundamentally. Then all of the problems that you're talking about, they are although very fundamental problems, they are very much strong problems. Obviously I can understand them, the scope thing, and
they're not just strong problems, they're just actual fundamental problems that would need to get taken into account if you're modeling of the problem. If you don't actually take that into account, if you see it as something separate that hopefully can be assailed, you might end up finding out that the way you've modeled it, like the way you've tried to scope out the problem, didn't take that into account, and it turns out that reality is going to look different because you didn't include the broader kind of selection dynamics. I think, let me see, I'm going to wrap up soon. I think it's good to talk about this. I think this feels like the thing where you already have certain ideas about how you want to go about things. So in that sense, I can't do much there. Then I do wish you well, wish you research.
I'm still working on it. I'll contact if something is there. Okay, but what I was saying is, at this moment we are working this way of working. The problem that seems fundamentally not possible at this moment can also seems to be possible when we have new set of definition of working, new set of definition for computation, new set of possibilities that machines can do. There was a time when machines can't do what machines can do now, and therefore the definition of fundamental problems of then is different than what it is now. Similarly, what is the
just make sure with your definitions that they're comprehensive enough, like in terms of the overall problem, and like covering all the relevant aspects. That's what I would point to here. And I think if you're talking about something like an algorithm or computation, like of course you can change what you're talking about, but I assume this involves some kind of deterministic kind of transformations of truth content, that means you're thinking about something else. It might also be that you're thinking of some kind of like more fluid kind of interactive kind of like.
It is more fluid, and the definition of computation is also not the definition of computation that we use at this moment for computation. Because if we use that definition of computation, that we cannot make anything like wisdom, because again using ears to trying to see, there's a different level of different type of thing that we need to work with.
But it might be worth separating out those concepts. I think usually how people talk about computation is about like transforming some kind of discrete truth content to let me see.
Basically function that maps one thing to other. It's a basically mapping of things. So that is not what I actually want to use. And this is what I'm saying. We need a whole different set of work. We need to define new computation. We need to define new mathematics. We need to define new ways of hardware. So it's not like we can just jump from intelligence to. This is my approach. We cannot just find shortcuts to alignment. That is what I'm saying. It's not like we made intelligence and then quickly we can do this kind of modification, this, that, and we can make alignment. And if we do that, there will always be that risk of deceptiveness. If machines can lie to us very easily, there will always be that chance that it is not actually doing that, as it happens with understanding, that it can imitate it can imitate intelligence, it can imitate wisdom, it can imitate alignment till it has got power, till it is deployed. So there will always be some risk of deceptiveness or some level of division between machines and us if we follow this quick way, this shortcut way that is supposed to be followed at this moment using in the community, that for alignment, for solving all the fundamental problems. But this way that I am talking about, this whole different way, this does not have chance of having those problems, because it is from a whole fundamental base. And we need to work on all of these bases, from defining new computation to designing new hardware to making new definitions of philosophies in more scientific way. So yeah, this is my approach. It is more rigorous, it is more lengthy, it is more long, but it is more reliable as well. It is not just a shortcut way to fix things. Because till now, in past 6 years, what I can see, all the shortcuts that has been introduced for fixing the alignment problem, they turn out to have some other problem. We have outer alignment problem, then there's inner alignment problem. We solve that, we have general misalignment problem. We solve that, we have some other problem, interpretability problem, and this problem, that problem. All of these problems keep on hitting some other level, because at one level, it's like no matter how close we go to machines, if machines are not getting close to us, there will always be some distance between them. This is what I can see. This is what I can see happening at this moment in the safety thing.
And the question is, how close do they need to get to us? So we can talk about things at the code, or like maybe some kind of hardware configuration level, and we can also talk about substrate, or just like the configurations, like the actual physical embodiment of the system. So the question will be something like, for something like that to stay stable long term, would it have to be basically something like a human, and hopefully a more enlightened human? Or would it, can you do something like this across silicon chip substrate, or like iron and copper and all the other kind of different kind of molecular configurations that would take this, and all the different production processes and kind of infrastructure that will be created around that. So there's a question like, how close does it need to be to us to actually act wisely or care for us, or to be selected for that? All right, I'm going to wrap it up. I'm going to leave it at this. Good talking with you. Sure. I appreciate you reaching out.
With you also.
Yes.
Thank you. Have a good day.